Hello viewers, I am Kausalya. Today we are going to solve one more problem related with nodal analysis. Find the values of the phasor voltages V1 and V2. So here this is the given circuit diagram, and this circuit diagram has one voltage source and one current source. So as a first step we are converting the voltage source to a current source. So converting voltage source into current source now. So here what is the basic Ohm's law? Ohm's law is given by the formula V is equal to I into R, and I is nothing but V by R. So here the value of V is 15 and the value of R is 5. So 15 by 5 gives 3. Therefore, here redrawing the circuit 3 amps, and here we have 5 ohm resistor in series. That resistor comes in parallel. So 3 amps, 5 ohms, and here this again these two parameters, these all four we are drawing the same. Right? Now we are going to apply KCL at node 1 as well as to the node 2. So here when you apply KCL at node 1, you see here this is given by V1 by 5 plus V1 by J10, and again this 2 ohm is connected between V1 and V2. Therefore V1 minus V2 by 2 is equal to 3. That is, sum of current flowing away from the junction is equal to sum of current flowing towards the junction. So here this 3 amps flow towards V1. Therefore here it is written as 3, and these 3 parameters are written on the other side. Now we are going to solve this equation. That is, we are going to simplify this equation. So 1 divided by 5 is 0.2 and 1 divided by 10 is 0.1, and again 1 divided, that is V1 minus V2 by 2 gives you 0.5. Therefore 0.2 V1 minus, here whenever this J term is moved to the numerator part, there is a sign change. So here it is plus J. I am moving this to the numerator, therefore it becomes minus J. Therefore, minus J 0.1 V1 plus, here 1 by 2 is 0.5. Therefore, 0.5 V1 minus 0.5 V2 equal to 3. Again, we are combining V1 terms together, V2 terms together. So, here you see, it is 0.25, 0.2 V1 plus 0.5 V1 gives 0.7 V1 and minus J 0.1 V1. Here, we are having only one J term, so we are keeping that as such. And here it is minus 0.5 V2 equal to 3. Again, when I take V1 commonly outside, this term reduces as 0.7 minus J 0.1 V1 minus 0.5 V2 equal to 3. Name this as equation 1. In the same way, now we are going to apply KCL at node 2. So again, when you look back at the diagram, you see how many elements are connected with node 2. So this is our modified circuit diagram. Totally 1, 2 and 3. 3 are connected. So when you write the equation, here it comes V2 by minus J2 plus again V2 minus V1 by 2, which is equal to 2 with an angle of 30 degrees. So this is our equation. So here is the equation what I have just said. Now again we are going to simplify. So 1 by 2 is 0.5 and here I have minus j. When I move this minus j to the numerator, it becomes plus j. Therefore plus 0.5 j V2, and here 0.5 V2 minus 0.5 V1 is equal to 2 with an angle of minus 30 degrees. So again when you simplify this, here it becomes minus 0.5 V1 plus, here V2 is common. So when I take V2 outside, the remaining terms are 0.5 plus J 0.5. Right, and here I am converting this polar form to rectangular form. So here it is 1.732 minus J1. So name this as equation 2. Now we are going to solve equations 1 and 2. So here this is our equation 1 and this is our equation 2. Now we are going to write these equations in the form of matrix. So here we have 0.7 minus j 0.1 and here minus 0.5, that is coefficients of V1 and coefficients of V2 here. V1, V2 which is equal to, here it is 3 and here it is 1.732 minus J1. Now we are going to find the values of del 1, del 2. So what is del? Del is nothing but determinant of this matrix. So when you take determinant of this matrix, you see here it is 0.7 minus j 0.1 minus 0.5. Here minus 0.5 and 0.5 plus j 0.5. So when you solve this, here it becomes 0.7 minus j 0.1 multiplied by this term and minus of minus 0.5 into minus 0.5. Therefore, it is minus 0.5 the whole square. So, when you multiply and simplify, here we finally end up with 0.15 plus j 0.3. Again, I am converting this rectangular form to polar form. The next thing is del 1. So, how to find del 1? Here in this case, we are going to replace this first column by this voltage values. So when you replace, here we have 1.732 minus j1 and again here minus 0.5 and 0.5 plus j 0.5. So again when you simplify this, finally here we end up with the answer 2.569 with an angle of 22.9 degrees. So here the thing is, what is the necessity why we are converting the polar answer to rectangular form is finally we are going to do division to find the values of V1 and V2. Okay, that's why we are converting the rectangular form to polar form. The second thing is we are going to find del 2. So how to find del 2? We have to replace the second column by the respective elements on the right hand side. So again when you simplify, you see multiplying this term by this term and minus of 3 into minus 0.5. So here when you simplify, here we get the answer as 2.613 minus j 0.873 and in polar form it is 2.754 with an angle of minus 18.5 degrees. Now the value of V1 is nothing but del 1 by del. We know the value of del 1 as well as we know the value of del. So just substitute the values here. So how to find the value? You can divide this number 2.569 by 0.335. This gives the answer as 7.669. And here when you move this 63.4 to the numerator side, here it is with plus sign, right? There it becomes minus sign. So 22.9 degree minus 63.4 degree gives the answer as minus 40.5 degree volt. Right, this is your V1. And how to find V2? V2 is given by del 2 by del. Again, we know the values of del 2 and del. Here again the same thing. When you divide 2.754 by 0.335, this gives the answer 8.221. And again the same thing, when you move this 63.4 angle to the numerator, here this plus angle becomes minus. So minus 18.5 minus 63.4 gives the answer as minus 81.9 degree volt. Right. So finally we have calculated the values of V1 and V2 using the nodal analysis. So here the basic step what we have done is we have made the we have made the sources as same type. That is both the sources are converted, both the sources are of the form current source, right? Because one is voltage and one is current, so we can't proceed. Therefore, we are converting the voltage source to current source and we are proceeding with these things. If you want, even you can convert that voltage source to that current source to voltage source, but the process will be a bit tedious. Therefore, whenever you are asked to find the value of unknown voltages, you better convert this voltage source to current source. So that's all. If you have any doubt, let me know in the comment section. Thank you.